Here we're going to solve another category 1 triangle. We need to decide if we have angle, side, angle, or angle, angle, side. I see that I'm given 2 angles, but I need to decide kind of what order it's given to me. Now, angle, side, angle is where the side in between the angles is included, and AAS here is where the side is one of the corresponding sides. So when I look at here, C would go with gamma, but I am not given the information for gamma. So this is not one of the corresponding sides, so it must be an included side. So in that case, I have ASA. So working with an ASA triangle, I can definitely use law of sines to solve. So sometimes I just like to kind of write on the side and say, okay, I'm given alpha, I'm given beta. That means I'm going to need to solve for gamma. And then I have the lengths of the sides here, and C is given as 3. And so now I'm going to go on to solve for the rest of the triangle. So the first thing I can do is solve for my angle gamma. I see that I'm given 2 of the 3 angles, and so solving for that third will be pretty easy. So I can see that 35 degrees plus 17 degrees plus that measure of gamma is going to add to 180 degrees. Okay. And so then I can see that gamma is going to be 180 minus the 35 degrees minus the 17 degrees. And so gamma ends up being 128 degrees. This is my calculation for gamma. So here I get 128 degrees, and that is an exact value. So now what I've found is now I have this kind of matching pair, and when I have that kind of corresponding pair, then I know that I can use law of sines. So now to use law of sines, I can solve for A or B. It doesn't matter which one I solve for first. Let's start with A. So I'm starting solving with A, then I know that I'm going to need A and its angle, alpha, and then I need to use the pair C and its angle, gamma. So for here, I'm going to have sine of 35 degrees over A is equal to sine, okay, gamma is 128, all over 3, which is the length of its side. So now I just need to solve for A. So I can have 3 times sine of 35 degrees equals A times sine of 128 degrees. And then dividing both sides by sine of 128 degrees. Now I have a value for A. I'm going to go ahead and put that in my calculator. So you can start by pressing the division sign. I'm going to have 3 times sine of 35, and then all over sine of 128, and I get A is approximately 2.18. And then I can do the same kind of solving for B. I'm still going to use this known pair here so I still have sine of 128 degrees all over 3 on one side, and on the other side, I'm going to want sine of beta, which is 17 degrees, all over B, and then I can solve for B, so I get B times sine of 128 degrees equals 3 times sine of 17 degrees. And so B equals 3 times sine of 17 degrees all over sine of 128 degrees. So if I pull back here, then I am on top, I'm going to have 3 times sine of 17 degrees, and then on the bottom, sine of 128 degrees. And I get 1.11. So B is approximately 1.11. And there I have solved the triangle.